In the last lecture, we have developed the basic ideas of calculus which we use in almost all areas of physics. And today we will continue the discussion of calculus and we start to work out certain situations where these ideas of differential calculus can be developed. Hi everyone, I am Satish. And we will start with a particular situation where the position of the particle is given by an equation like this. X equal to a plus b t square. And we will analyze this motion and we can see that this is one dimensional because it depends only x alone is given, and this is the origin 0, and at t is equal to 0 it will be at a, at t is equal to 1 this will be at a plus b, at t is equal to 2 this will be at a plus 4b, like that. This particle will be moving according to this equation. Now let us use the idea of differential calculus to calculate the velocity of this particle as a function of time. Therefore, first we calculate the velocity of the particle as a function of time. And we know that velocity v is equal to the derivative of x with respect to time t, and this is equal to d by dt of a plus b t square, and a is a constant, its derivative is 0, b is a constant, derivative of t square is 2t, therefore this is 2bt. Therefore velocity as a function of time is 2bt. At t is equal to 0 second, at this point if it is 0 second, this is at a, therefore at this point we have the velocity equal to 2b. This is t is equal to 0, this is t is equal to 1, this is t is equal to 2, like that. 0, time is 0 here, t is equal to 1, therefore this velocity will be 2b. Here t is equal to 2, therefore this velocity will be 4b, like that. We can calculate the acceleration of the particle, a, that is equal to dv by dt, that is we have to differentiate this again, therefore d by dt of 2bt, 2b is a constant, derivative of t with respect to t is 1, therefore this is 2b. And we find that this is a constant. Acceleration is same always. This is v is equal to 0, in 1 second it reached 2b, in 2 seconds it reached 4b, like that. Therefore the acceleration is a constant. The rate of change of velocity is a constant. This is 2b, this is 0, therefore 2b divided by 1, that is 2b. This is 4b, this is 2b, therefore 2b divided by 1 is 2b. This is 4b, this is 0, therefore 4b minus 0 divided by 2 is 2b, like that. Therefore this is a constant acceleration. That is usually called uniformly accelerated motion. Uniformly accelerated motion. This is a uniformly accelerated motion. That is the acceleration, velocity, etc. of this. If we are asked to calculate velocity at t is equal to 1 second. We can simply say that velocity v at 1 second is equal to, that is 2bt, therefore that is equal to 2b. Velocity at 2 seconds will be equal to 4b, like that. Therefore, the particle, the entire details of the particle can be obtained from the displacement equation, that is equation for the position as a function of time, by doing differentiation again and again. We can start from x, differentiate once, we get v. We get v, differentiate once, we get a, like that. Now, imagine that we are asked to calculate the average speed of this particle. Average speed of the particle. Therefore, the average speed from 2 seconds to 4 seconds. That clearly is, we know that the average velocity is x t2 minus x t1 divided by t2 minus t1. Therefore, x t2 is a plus b t2 square. A plus b t2 square minus a plus b t1 square divided by t2 minus t1. That is equal to, a will cancel, b can be taken out, b multiplied by t2 square minus t1 square divided by t2 minus t1. That is equal to b multiplied by t2 plus t1. This is 6b. Therefore, the average speed of that particle will be equal to 6b. Since the acceleration is a constant, particle will not change direction. Acceleration is always constant if you have x as a quadratic function. If there is a t cube or t raised to 4 etc. here, that will not be a uniformly accelerated motion. Then the average speed and average velocity can be different. Here, for any function for which t is in second order, up to second order, up to quadratic, then the acceleration will be a constant, and this will be the situation. And also, we have another idea which is very important. We can calculate the average velocity. Here we have calculated the average velocity from the expression for x. Instead of that, we can calculate the average velocity from the expression for velocity, provided the acceleration is a constant. Therefore, we can write that relation as, for uniformly accelerated motion. This is only for uniformly accelerated motion. The previous case is applicable always, but this is applicable only for a uniformly accelerated motion. There, V average is equal to V T2 plus V T1 divided by 2. And here we can see that this is 2B T1 plus 2B T2 divided by 2, that is equal to b multiplied by t1 plus t2, that is equal to 6b, as we have obtained earlier. So if the particle moves with uniform acceleration, that is, if the displacement x is given as a function of time up to second order, then we can always calculate average speed by this method, vt2 plus vt1 divided by 2. We now take one more case. We can see that at t is equal to 0, particle at rest. That is, t is equal to 0, particle is at rest. And the position at which the particle is at rest at x is equal to a. Therefore, the particle starts from rest and it starts from the point a. So, a lot of information can be extracted from a single function if you apply the methods of differential calculus. Let us analyze one more function, that is x is equal to t cube minus 12t plus 20. This is a cubic function. Now we are asked to calculate one, velocity and position at t is equal to 0. Second, check whether a is equal to a constant. Third, when and where the particle is at rest. Now we have to calculate these situations. So velocity and position. Position at t is equal to 0 x0 is clearly 20 meters. Therefore, if this is the axis, this is 0, this is 20 meter, this is t is equal to 0. At t is equal to 1, this is 21 minus 12, that will be 9 meter. This clearly tells you that the particle is moving towards the left. Therefore, we expect a velocity to be negative. Let us calculate that. V is equal to dx by dt is equal to t cube, derivative is 3t square, 12t, derivative is 12. Therefore, at t is equal to 0, v0 is equal to, t is equal to 0 means this is minus 12 meter per second. Therefore, at this point, the particle moves in this direction with a speed equal to 12 meter per second. That is minus 12 meter per second because it is moving towards the left. At t is equal to 1 second, that is when the particle is at 9 meter, this will be 3 minus 12. Therefore, V1 will be equal to minus 9 meter per second. Therefore, here the particle will be moving in this direction with a speed of 9 meter per second, because v1 is 3 minus 12. Similarly, you can calculate the velocity at any instant of time, because the velocity is obtained as a function of time. Now, check whether A is equal to a constant. A is equal to dv by dt, and here we can see that V is 3t square minus 12. Therefore, this is d by dt of 3t square minus 12. That is equal to d by dt of 3t square is 60. This depends on t. Therefore, A is not equal to a constant. Therefore, non-uniformly accelerated motion. Remember that if you are asked to calculate the average speed and velocities, it will not be equal in this particular case, because acceleration is not a constant. Acceleration varies with time. And also you can see that at t is equal to 0, the acceleration is 0. At this point, acceleration is 0. But when it reaches here, at t is equal to 1, acceleration will become 6 meter per second square. When it becomes t is equal to 2, the acceleration will become 12 meter per second square. Or acceleration varies with time. It is not a constant. Now, when and where the particle is at rest. Particle is at rest means the velocity is equal to 0. So, V is equal to 0 implies that 3t square minus 12 is equal to 0. T square is equal to 12 divided by 3 equal to 4. T is equal to plus or minus 12. Plus or minus 2. Remember that here we have a minus 2 value, but as we have seen earlier, minus 2 actually represents a situation 2 seconds before t is equal to 0. We need to consider only the situation after t is equal to 0. Therefore, we need to take only t is equal to 2. At t is equal to 2, x2 will be equal to t cube, that is 8 minus 12t, that is 24 plus 20, that is equal to 4 meter. Therefore, the particle reaches here. Say this is 4 meter. Here the particle will come to rest. So when the particle is moving in this direction, there is an acceleration in that direction. Therefore, the speed decreases and reaches 0 at this point. After that, that is, for example, t is equal to 3 seconds. T is equal to 3 seconds. This particle velocity will be equal to 3 multiplied by 9, that is 27 minus 12, that is equal to 15 meter per second. That is, the particle moves in that direction, positive direction. Therefore, the particle starts here at 20 meter. At 20 meter it starts here. At t is equal to 0. At t is equal to 0, it will have a speed equal to minus 12 meter per second in this direction. That speed decreases and reaches 0 at 4 meter. Then it increases and moves in that direction. Therefore, in this situation, if this particle is moving not unidirectionally, therefore here In this question, you don't need to calculate the average speed and velocity. But if you are asked to calculate average speed and velocity, in this situation, average speed and average velocity will be different. The total distance traveled and total displacement also will be different. And what you have to do in such situations, we will see in subsequent questions. And also you should remember that the Vt1 plus Vt2 divided by 2 formula cannot be used in this situation. That is, you cannot calculate the average velocity directly from velocity expression using the method we have seen earlier. But by using integral calculus, you can calculate that you will be, I will discuss that when we take up the integral calculus. But using differential calculus, you cannot calculate the average of this because acceleration is not a constant. We will work out this question. S is the function of time. It is given as 15t minus 0.4 t square. And then we have to calculate when and where the velocity is 7 meters per second. So we have to work out the velocity, and the velocity as a function of time can be written as v is equal to ds by dt. And we have to take the derivative of this. Derivative of 15t is 15 with respect to t, and derivative of t square is 2t, 0.4 is a constant, therefore minus 0.8 t. The when and where the velocity is 7 meters per second. We have to first calculate when. That is 15 minus 0.8 t is equal to 7, or 8 is equal to 0.8 t, or t is equal to 8 divided by 0.8 is equal to 10 seconds. Therefore, the particle will have a velocity 7 meters per second when time equal to 10 seconds. Where? You have to substitute this 10 in this equation. S is equal to 15 multiplied by 10 minus 0.4 multiplied by 10 square. That is equal to 150 minus 0.4 into 100. That is equal to 150 minus 40 equal to 110 meter. Therefore, particle will acquire a velocity equal to 7 meter per second when it is at 110 meter from the origin. It actually starts from the origin because t is equal to 0, then s is equal to 0. And the velocity at t is equal to 0, we can see that this will be equal to 15 meter per second. So it will start from the origin with a velocity 15 meter per second, or at t is equal to 0, it is at the origin and its velocity will be 15 meter per second. And then it continues to move because it has an acceleration a equal to the derivative of this, that is the acceleration will be 0.8 minus 0.8 meter per second square. Therefore, when it moves, the acceleration is negative, therefore its speed will decrease, and finally when it reaches 110 meter, it will acquire a velocity 7 meter per second. It starts with 15 meter per second, it continuously decreases velocity because acceleration is negative, and therefore at 110 meter it acquires a lesser velocity, that is 7 meter per second. That is, all the details of this motion can be obtained from the expression for displacement if you use the differential calculus. Next question is based on the maxima minima principle which we have seen. Consider a velocity v which is given by 60 square minus 60 cube. Find the maximum velocity and minimum velocity. Here in this question we have been given the expression for velocity. So we have to find at which point it is maximum and at which point it is minimum. We know that for maxima and minima, dv by dt this maxima and minima combined together is called an extremum in physics. This is the term used for both maxima and minima. And at extremum points, acceleration will be 0 because dv by dt is equal to 0. That is a very important point you have to remember. At maximum velocity and at minimum velocity, acceleration will be 0. Now, we can work out dv by dt. dv by dt is equal to t square is 2t, there is 6 there, therefore 12t minus 6 into 3t square, that is 18t square. This is equal to 0. And this is t multiplied by 12 minus 18t is equal to 0. This is a quadratic equation, therefore it has two solutions. One solution is t is equal to 0 and the other solution is 12 minus 18t equal to 0, or t is equal to 12 divided by 18, which is equal to 2 by 3 second. Therefore, the particle will acquire maximum velocity or minimum velocity at time t is equal to 0 and time t is equal to 2 by 3 second. Now we have to find out which is maximum and which is minimum. And we know that for that we have to take the second derivative. And when the second derivative is negative, it is a maximum, and second derivative is positive, it is a minimum. The method is very simple. You take the second derivative of this, that is second derivative of 12t minus 18t square, and substitute the value of t equal to 0 there. Check whether it is positive or negative. If it is positive, it is minimum. If it is negative, it is maximum. Therefore, we can find the second derivative, d square v by dt square is equal to 12t, the derivative is 12, minus 18t square, this is 18t square, therefore the derivative is 36t. At t is equal to 0, d square v by dt square is equal to 12, which is positive. Therefore, t is equal to 0 corresponds to a minimum. Therefore, V minimum is equal to, you put t is equal to 0 here, that is equal to 0. So the minimum value of velocity for this motion will be equal to 0. The particle will be at rest. That is the minimum value. Now, at t is equal to 2/3 second, d square v by dt square is equal to 12 minus 36 multiplied by 2/3, that is 12 minus 24, which is equal to minus 12. Therefore, the second derivative is negative. This is negative. When the second derivative is negative, it is a maximum. Therefore, velocity maximum at t is equal to 2 divided by 3. Now we can work out the value of that. What is the maximum velocity? V is equal to 6 multiplied by square of 2/3, that is 4/9, minus 6 into cube of 2/3, that is 8/27. That is equal to 24/9 minus, there is a common factor 3, therefore this becomes 9 and this becomes 2, 2 into 8 is 16. Therefore this is equal to 8 divided by 9 meter per second. That is the maximum value. Therefore, in that motion, the minimum value is 0 and the maximum value is 8 divided by 9 meter per second. After that, the velocity will decrease because this is maximum. After this, the velocity will increase because this is minimum. Now we will work out this question. That is a very interesting question, and you have to understand all the peculiarities of this question. Because first thing is that it is a cubic function, therefore it is not a uniformly accelerated motion. Particle moves with a uniform acceleration only if the highest power is t square. Now find the velocity. That is the first thing we have to do. And we know that the velocity v is equal to dx by dt. And dx by dt is 3t square. By now you are familiar with taking the derivative, therefore I am taking it in the first step, plus 9. At t is equal to 2 seconds, v2 will be equal to 3 multiplied by t square is 4 minus 12 multiplied by 2, that is 24, plus 9. That is 12 plus 9, 21, minus 24, that is minus 3 meter per second. Therefore, at 2 seconds, the particle moves in the left direction or in the backward direction. At t is equal to 4 seconds, v4 is equal to 3 multiplied by 16 minus 12 multiplied by 4 plus 9. This is 48, this is 48, they will cancel, and this is equal to 9 meter per second. So at t is equal to 4 seconds, the particle velocity is positive, therefore it moves in the forward direction. So that is the first part. When is the particle at rest? Rest means v is equal to 0. Therefore, 3t square minus 12t plus 9 is equal to 3 multiplied by t square minus 40 plus 3 equal to 0. We can factorize this. 3 multiplied by that I am doing for the next part D. T minus t square minus 40. This 4 can be written as minus 1 minus 3, which product is 3. Therefore, this is t minus 1 multiplied by t minus 3. This is equal to 0. This is equal to 0 at t is equal to 1 second and t is equal to 3 seconds. Therefore, at t is equal to 1 second it is at rest. At t is equal to 3 seconds it is at rest. Therefore, when is the particle at rest means at t is equal to 1 second and t is equal to 3 seconds. Now the next part, that is very interesting. When is the particle moving in the forward direction? Forward means velocity is positive. Here we know that this can be positive in two situations. When t minus 1 is positive and t minus 3 is positive, this will be positive. When t minus 1 is negative and t minus 3 is negative, this is positive. Therefore, first of all, we will take time t as 0 to 1. That is, t is greater than 0, less than 1. When t is greater than 0 and less than 1, we know that t minus 1 will be negative, t minus 3 will also be negative. Therefore, t minus 1, t lies between 0 and 1. Say it is 0.5. 0.5 minus 1 is negative, 0.5 minus 3 is negative. Both are negative. Therefore, V positive, or it moves in the forward direction. Now, t between 1 and 3, that is, t is greater than 1 but less than 3. When t is greater than 1, this will be positive. When t is less than 3, this will be negative. This is positive, this is negative. Therefore, in this interval, V is negative. Because when t is greater than 1, this will be positive. When t is less than 3, this will be negative. Therefore, this will be positive, this will be negative. Therefore, the product will be negative and the velocity is negative. Therefore, this moves in the backward direction. When time is between 3 and above, we know that this is 3 and above, this will be positive and this also will be positive. Therefore, t is greater than 3. Then this will be positive. For example, imagine this is 3.5. This is 3.5 minus 1, that is positive. This is 3.5 minus 3, that is positive. Therefore, the product will be positive, and therefore in this situation, V is positive. And therefore it moves forward. Therefore, when is the particle moving forward means when t is greater than 0 and less than 1, then that is moving in the forward direction. When t is greater than 3, then also it is moving in forward direction. Therefore, it moves in the forward direction from 0 to 1. From 1 to 3, it is moving in the backward direction. After 3, it is again moving in the forward direction. Therefore, the particle starts from here, reaches here, moving forward up to t is equal to 1 second. Then it comes back at t is equal to 3 seconds, it will reach here, and then it will move in this direction. So the particle is moving like this. When that is the situation, we know that the particle changes direction. When the particle changes direction, we have to take the total distance in a peculiar way. You are asked to calculate the total distance for first 5 seconds. You should not make the mistake to subtract x0 from x5, because that gives the displacement. Since the particle is changing direction, displacement is not equal to distance. Then what will you do? In that situation, you have to split the time into different segments. For example, from 0 to 1, it is moving in the positive direction. You calculate the distance for 0 to 1. Then you calculate the distance from 1 to 3. Then you calculate the distance from 3 to 5 and add all of them together. That will give you the total distance traveled. Therefore, when you calculate the total distance, you should be careful. In questions, when there is this type of motion, that you should not make the mistake of x5 minus x0. That gives you the displacement. But the distance traveled is the sum of all this. So we actually have to work out x1 minus x0 plus x3 minus x1 plus x5 minus x3. You have to work out in this manner, because you have to divide it into 3 time segments. 0 to 1, you calculate the distance. 3 to minus 1, you calculate the distance. 5 to 3, you calculate the distance. And take the modulus of all of them. You should not take the sign. It may happen that something will become negative, but you should not subtract. You add all of them, because distance is always a positive quantity. You have to take the modulus of that difference. So we will work out that. That is a very important concept. You should never forget that when you work out the questions. x1 minus x0. x1 is equal to, this is 1 minus 6 plus 9, that is equal to 4 meter. x0 is equal to 0. x3 is equal to, this is 27 minus 54 plus 27, which is again equal to 0. x5 is equal to, this is 125 minus 6 into 25, that is 150, plus 9 into 5, that is 45. That is equal to 20 meter. You can work out this x1 minus x0. x1 is 4 meter, x0 is 0, therefore this is 4 meter. x3 is 0, x1 is 4 meter, therefore x3 minus x1 is 0 minus 4 meter, this is minus 4 meter, but the modulus is equal to 4 meter. And this is x5 is 20 meter, x3 is 0, therefore this is 20 meter. So the total distance equal to 4 plus 4, you should not put minus 4, 20. That is equal to 28 meter. If you work out x5 minus x0, you can see that x5 is 20, x0 is 0, therefore this will only be 20 meter. Here also you can split it into 3 different parts and calculate the displacement, there is no problem. But you should not take the modulus. Instead of that, you have to take the displacement with sign. Then this sum will be 4 plus minus 4 plus 20. That will again be 20 meter. But if the displacement is asked, you don't need to split into different time segments. You can simply take xy minus x0. But if the total distance is asked in the question, and if the particle changes direction, as we have seen here, for that you have to factorize the velocity expression and check whether the velocity becomes negative at some point or not. If it is all of them is negative or all of them is positive, then it is okay. But if some time segment it is positive, some time segment it is negative, then it means that it changes direction. Then you have to split the time for the positive motion, for the negative motion, for the positive motion, like that. Then you have to take the magnitude or the modulus of the differences and add them together. That will give you the total distance. So you should be very careful about this. In the next lecture, that is lecture number 5 of Kinematics Basics, we will see a special method to derive the equations of kinematics using differential calculus alone. In most of the textbook, they derive the equations of kinematics using integral calculus. But we develop a method which is very useful in several situations to derive the equations of motion using differential calculus alone. That is a special lecture not given in most of the textbooks, and also it is useful to develop several series of cos x, series of sin x, e raised to x, 1 plus x raised to n, etc. by using differential calculus alone. And after that we will pass on to the integral calculus and use it to derive the equations of motion. But this is rather special. That will be dealt with in lecture number 5. Thank you.